Hi, welcome to my video on function notation with radicals. We're going to practice this right from the start because we've already done similar problems. Find each as a radical in simplest form. So this is function notation, and there is a unit on called relations and functions, and in that unit, videos 19 to 22 does examples and problems related to the function notation. So this is a backup to that, only we're using irrational numbers and roots. So f of x equals 2x plus 3. Find the f of 4 plus root 3. So that's the f of 4 plus root 3. Notice this is an x, so that means you sub in 4 plus root 3 in the place of x. So when you do, there's the f of 4 plus root 3, which is x. So here I put 4 plus root 3 in the place of x with a bracket. So 2 times 4 is 8. 2 times root 3 is 2 root 3 plus root 3. And when you add, you get 8 plus 2 plus 1 is 3, so it's 3 root 3. So note the f of x, the x is being replaced with whatever is in this bracket. Number 2, the p of x equals x squared plus 4x minus 9 root 2 minus 2. We want to find the p of root 2. So the p of root 2 means x is root 2. So I'll put a root 2 in wherever I see an x. So there's the root 2 gone in. So root 2 squared, root 2 times root 2 is root 4, which is 2. 4 times root 2 is 4 root 2. And we cannot simplify, subtract 9 root 2, subtract 2. Like terms, 2 and a negative 2 cancels out, and 4 subtract 9 is a negative 5 root 2. Number 3, the g of x equals x squared, and we're looking at the g of root 5 minus 1. So the g of root 5 minus 1, that's what x is. So we sub that in for x, root 5 minus 1 being squared. And that's square means to multiply by itself, so let's do that. That means we write it down twice. First, root 5 times root 5 is 5. Root 5 times negative 1 is negative 5. Negative 1 times root 5 is negative root 5. Negative 1 times negative 1 is a plus 1. And like terms, we have a 5 add on 1 minus root 5 minus root 5. So we get 6 minus, that's a 1 there, and that's a 1. So negative 1 is negative 2 root 5. Number 4, the h of x is equal to the x minus 3 being squared plus root 3x. And we're looking at the h of root 6 minus root 3. So we'll sub that in the place of x. So x is here, so that's root 6 minus root 3 plus root 3. And we get root 3 times x, and x is root 6 minus root 3. So it takes a bit of getting used to it, but the more practice you do, the better you get, obviously. That's the way I approach math. I always practice. When I add those, they cancel out, and I get root 6 squared. I simplified the inside of brackets, so what I'll do is just show you that. I cannot simplify this one, so remember when we're working these out, think about we're using PEM, PEMDAS, or BEDMAS. So I have to do the inside of this bracket first, so that's done. Now I'll do the next step, I'll do the exponent. So root 6 squared is 6. So I got the exponent done. Let's cross that out. And next we do multiplication division from left to right. So I have to multiply these two first before I add on the 6. So 6 root 3 times root 6 is root 18. And root 3 times root 3 is 3. And the root 18 is 9 times 2. So the root of 18 is 3 root 2 minus 3. So I have a 6 minus 3 plus 3 root 2. So the final answer is 3 plus 3 root 2. And you can't add those because they're not like terms. And we have a different other problem here. Now solve for x. The f of x equals 4 root 3x minus root 50. And the f of x equals 7 root 2. So since this is the f of x and this is the f of x, that means that these two must equal each other. So 4 root 3 minus root 50 must equal 7 root 2 by the transitive property. Because both of these expressions is equal to the f of x, so they're equal to each other. So I have to simplify first, so I see the root of 50. And again, 50 is 25 times 2. So the root of 50, square root of 25 is 5, so that's 5 root 2. Remember, we simplify the inside of a radical to find out what radicals we're going to have simplified. And the x's we're solving, so the x stays on the left side, and the variable or the constants or numbers move to the right side. So minus 5 root 2 moves to plus 5 root 2. So 4 root 5x equals, I add these up, I get 12 root 2, add like terms, and I divide both sides by 4 root 5. They cancel out to give me 1, so that's 1x. 4 into 12 goes 3, so I get a 3 root. I can cancel that down first. Now I can multiply by root 5 over root 5. Notice I took the 12 and divided by 4 and made it easier. So now I'm doing the rationalized denominator by multiplying by the conjugate. And that, let's go up here. And that gives me 3. Root 2 times root 5 is root 10. And root 5 times root 5 is 5. So that's the answer. Or you could have 3/5 root 10, your choice. But notice they're both equal to each other, so we're solving the equation. Let's continue. More practice. Find each radical in simplest form. So, same thing again. The t of x equals 15x. What's the t of? 1 over root 10. So t of 1 over root 10. Which means that x is 1 over root 10 subbed in. This is 15 times that. So that's 15 over 1. So that's really 15 times 1 is 15. 1 times root 10 is root 10. And now we have to rationalize. So the denominator, the conjugate is root 10. So root 10 top and bottom. And that gives us 15 root 10. Root 10 times root 10 is 10. And we have a simplified denominator is a rational number. So looks like 5 is a factor of both of these. So 5 into 15 goes 3. 5 into 10 goes 2. So we get 3 root 10 over 2, or 3 over 2 root 10. Your choice. I keep stressing that. And the same here. The g of x equals x squared plus 6x minus 9 root 2. Find the g of 4 over root 2. So the g of 4 over root 2. And notice that's what x is. See, g bracket. X is 4 over root 2. So 4 over root 2 is subbed in for x. 4 over root 2 is subbed in for x. And there's no x there, so I can't put it in. Now I have to take 4 over root 2 and square it. So let's go over on the side and take 4 over root 2 times 4 over root 2. That gives us 16 on top. Root 2 times root 2 is 2, so that works out to be an 8. Notice I did the workings over on the side. And 6 times 4 root 2, 6 over 1, so that becomes 24 over root 2. Okay, we got the multiplication done. Notice PEMDAS, we did the squaring first, then we did the multiplication. Now we're going to simplify each of these. So 8 is okay. And we multiply 24 over root 2 by root 2 over root 2. So that gives us 24 root 2 over 2. Root 2 times root 2 is 2. Minus 9 root 2. Let's keep simplifying. That's an 8. 24 divided by 2 is 12. Root 2. Minus 9 root 2. And like terms, 8 is all alone. Leave it. 9 or 12 subtract 9 is 3. And it's a root 2. Fully simplified. Number 3, the v of x equals root 6 x squared. So what's the v of root 6 minus root 3? So root 6 bracket root 6 minus root 3. Now, again, let's look at PEMDAS. We can't work out inside the brackets, but we have to do the square first. We have to square this first according to this rule. And to square it, we multiply it by itself, and we'll use FOIL on that. So I'm going to multiply those two first. Here I go. Root 6 times root 6 is 6. Root 6 times root 3 is a minus root 18. Negative root 3 times 6 is a negative root 18. Negative times a negative is a positive. Root 3 times root 3 is 3. And that gives us root 6. Simplify in here. And 6 and 3 is 9 minus 2 root 18. But we simplify the root of 18. The root of 18 is the root of 9 times 2. So that's a 3 root 2. So we got 2 times 3 root 2. That's what the root of 18 is. And we keep simplifying inside till it's fully completed. We have to, by PEMDAS, we have to do the multiplication before subtraction. So that gives us a negative 6 root 2. So the inside is fully simplified. And now we multiply by root 6. So root 6 times 9 is 9 root 6. And root 6 times negative 6 root 2 is a negative 6 root 12. But the root of 12 can simplify. Notice, because 12 has a perfect square. So 12 is 4 times 3. So the root of 12 is the root of 4 times 3. So the root of 12 becomes, square root of 4 is 2. So that's a 2 root 3. And that simplifies to 9 root 6 is okay, minus 6 times 2 root 3 is 12 root 3. Notice you multiply the 6 by the 2, not by the root 3. And that's a root 6 and root 12, so there's the final answer right there. Just more work, a review. The function notation allows me to do more practice on my radicals. And f of x is x plus root 2 over x minus root 2. Work out the f of root 3. That means wherever I see an x, I put a root 3. So I see an x, I put a root 3. I see an x, so I'm subbing in root 3. So now that I have that subbed in, I have a binomial on the bottom, so I have to rationalize it. So I multiply by root 3 plus root 2 is the conjugate. So the top is root 3 plus root 2. And when you let's multiply the bottom, because the bottom is conjugate. So we know when these are binomial conjugate, all you got to do is multiply root 3 by root 3 to get a 3. You multiply root 2 by root 2 to get a 2 with a minus in between. Now we're multiplying these two by FOIL. So we get root 3 times root 3 is 3. Root 3 times root 2 is root 6. Root 2 times root 3 is root 6. And the outside, root 2 times root 2 is 2. So that gives us, and I could write all this down again, but it's easy to do. 3 add on 2 is 5. 1 root 6 add on 1 root 6 is 2 root 6. 3 minus 2 is 1. The numerator and denominator are fully simplified, so 1 divided into 5 plus dividing by 1 keeps the number or the variables the same, the expression's the same. And there's the final answer when you're working out your sub in your root 3. Again, it's a review of function notation and also review of radicals in that concept. Remember, I always keep bringing back and reviewing earlier concepts. So as the math goes on, that'll be my goal. Always bring back the earlier skills. Okay. If you like my video, click the like button, click the subscribe button, and click the notification bell because there are more videos coming your way. Visit my math website at www.mathfullyexplained.com to find more information about me, videos, and the content. The content is the units that are on my YouTube channel. Thank you for viewing my video. Bye-bye.